All right, I'm looking at problem 13 here. We are going to complex polar form. So same sort of idea that we find the r value by doing square root of the x value squared plus the y value squared. That comes out to be 1 plus 3. So r is equal to 2. That's great. Then I look at the theta. The theta is equal to the inverse tangent of the y value divided by the x value. And this is in my original z is in quadrant 4 because it has a positive real part and a negative imaginary part. So the inverse tangent, if you just do it on your calculator, I guess you can't use your calculator here, but it would give you the correct value. So if you think about where the y value is larger than the x value, because that's what I'm seeing with a larger number on top than on bottom, on your unit circle, that happens at a 60-degree angle or a negative 60-degree angle. And so that's how you can recognize that the theta here is negative pi over 3. Because pi over 3 is the same as a 60-degree angle. So there is some practice that you'll need to do in memorizing the values on the unit circle. I guess there's no way around it for a no calculator question like this. So to represent it in complex polar form, you would say that z equals 2 cis of negative pi over 3, or you could do my preferred form of Euler's form, 2e to the I negative pi over 3. That's part A. Okay, part B. Hence, find the smallest value for n such that z to the n is in r plus. In other words, I want to raise this to a power and get a positive number out of it. I think they may have misstated the question because the answer is, well, they didn't tell us what n is. Do you know what I'm saying? So we could say n is equal to 0, and then we would get z to the 0 is equal to 1. Or we could even say n is a negative number, and we would be able to work our way backwards down. So I think they just meant usually when we use an n, we talk about integers or even positive integers. So I'm assuming they want us to think about positive integers here and ignore the sort of trivial answer of n equals 0, which is, I guess it's sort of one of those badly written questions. So anyway, let's assume that that's the way they meant it, that we want to find a positive integer n, and when we raise z to that power, we get r plus. And so remembering that raising a complex number to a power is just rotating by that angle. And so what I just need to do is figure out how many times do I need to rotate by negative pi over 3 until I get to the positive arm of the x-axis. So I don't want to land on pi because that would be an r minus. That would be a negative real number. I want to land on 2 pi or on negative 2 pi. And so the question then is z to the n is equal to 2 to the n times the cis of n times the theta, which is negative pi over 3. And I want to know, when does n times negative pi over 3 equal negative 2 pi? Because I want to find a positive value for n, the assumption I made earlier, that's why I'm making it equal to negative 2 pi. So if you multiply by 3 and divide by pi, you get n is equal to 6. You should be able to sort of visualize this, that the first complex number is 60 degrees below the x-axis, and it takes 60 degrees to get all the way around the circle, and that's why we got n equals 6. Now we want to find the value of 1 minus I root 3 to the 15th. We have our formula right here. So z to the 15th is just going to be 2 to the 15th times the cis negative 15 pi over 3, which is a nice multiple of pi. It's 5 pi, negative 5 pi, which is on the left side of the origin. So that has a real value of negative 1 and an imaginary value of 0. So z to the 15th is equal to negative 2 to the 15th. I don't care what that is written out in its decimal expansion. Negative 2 raised to the 15th power is the exact value. So there you go. That's it for question 13.